Welcome, everyone. Welcome to our talk, M&Ms Your Way. Build a fun Flutter-powered candy dispenser on a Raspberry Pi 5 with live treats. Now, yeah, the title is very long. I'm glad that I pronounced it more or less the right way, so the presentation is off to a good start. Let's get on. So, even though this talk is only 40 minutes long, we do have a short agenda. First, we'll speak a little bit about us, Payam and me. Second, we will talk about the hardware being used in this project. Then we will explain to you how to set up Flutter to develop on embedded devices. And last but not least, we will go through the steps to create this M&M machine. So the hands-on guide for you to see the steps to really build this, the fun part of this presentation. So, about us. My name is Moritz. I'm a GDE for Flutter and Dart. I'm one of the founders of SnapX, which is a Munich-based Flutter agency. And I'm one of the organizers of Flutter Munich. So if you have any questions for collaborations or a talk or so anything regardless if it's the company or the Flutter meetup, the Munich meetup, please feel free to reach out to me afterwards. But enough about me. Yeah, really quick, next is Payam.
So hey everyone, my name is Payam. I'm a software engineer at SnapX. I'm also one of the organizers of Persian Flutter community and maintainer of Toastification and several other open source packages. So if you're interested about open source, embedded, or any other topics, just reach out and let's have a talk. Thanks.
So let's talk hardware. I mean, you've all seen this is a Flutter conference, and there will be not too many people bringing hardware and the M&M machine with them on the stage. So let's talk about that. Well, the hardware we have and we're using here is right there. Okay, this is maybe not the best view for that, so let's go through those parts one by one. First, and I would say the heart of this whole thing, we have a Raspberry Pi 5. We're using the one with 4 gigs of RAM and a SD card with the Raspberry Pi operating system on it. Oh, okay, I wanted to tell that later, but yeah, we're using the Raspberry Pi operating system on it. And if you ask yourselves a question, do I need 4 gigs of RAM? Should I get the 8 gigs of RAM? Well, now you have the chance. We have a 4 gigs of RAM model here. You'll see firsthand how a Flutter application running on it, a very heavy on visual parts Flutter application is working on it. Spoiler alert, it works very, very well. So don't worry about it. You can see that later. We're using a 10-inch display from Waveshare. Yeah, it's an IPS panel, and we don't want to speak too much about the display, but we just wanted to give you a hint that we work now with 6 or 7 models of Waveshare displays with embedded Flutter projects. They all just work fine. So we don't know if other companies or other displays work as well. We can only tell you if you want to get started, the quality is really good, and you can be sure, at least for the ones we tried, it worked, everything worked fine. You just have the community behind it, and I think they're very well tested, so we can recommend getting one of these for starting out. Next, the part, you can see it in front of you. We used some quality serial dispensers where we're not telling you where we ordered them. The very special thing about them to say is maybe the quality material mix, how it was stated here, of 50% plastic, 40% plastic, and 10% plastic. So next part we have is the servo controller. We're using one by Adafruit here, and this part is, to describe it, it's more or less the translator between the Raspberry Pi and the servos. It can connect up to 16 servo controllers, and those are controlled by a pulse width modulated signal. The board itself connects to the Raspberry Pi through I2C. So this is just a very common bus system to talk between different boards or different chips in the embedded world. And what it brings to you, or why we're using it, is that with I2C, it not only brings the I2C connection and everything, it also brings a software library that you can use to drive the servos. So the board essentially brings us a software library where we have functions that run on the Raspberry Pi. For example, in Python, most of them also, the board suppliers offer C code. So you have this. So it does more or less the whole translation from code till it working and moving servo. Write what we need. Last but not least, I use the word very often, we talk about it all the time, we are using servo motors. We're using 4 of them. What we have to say about the servo motor is just it's one with a continuous rotation, which means there's essentially 2 different types of servos. One drive from, let's say, an angle of minus 180 degrees to plus 180 degrees. And if you give the lowest signal possible into it, it will drive to the minus 180 degrees or minus 90 degrees, if that's how far you can drive. If you give the highest signal, it will drive to the plus 180 degrees. If you have a continuous rotation servo, if you give in the highest signal, it will rotate as fast as possible in one direction, lowest signal, fastest possible rotation in the other direction. So as you can see, what we want is a continuously rotating to drive the dispensers. Therefore, we're using the continuous rotation servos. So now we went through all of the parts we need, but how do we get them together? How do we attach them to one another? Well, okay, yeah, you can see the machine already here, so you know it. Obviously, yeah, we designed and 3D printed some parts. So, yeah, what we need is something to hold the serial dispenser and attach the servos to it. Therefore, we use Autodesk Fusion because it's free for personal use. So this is a conference talk. I think this falls under personal use. It's just a private project. We use this. It even works on Mac very well. A few years ago, when I was still at university, it only worked on Windows. But now you can design on Mac and then print it with a BampUlab A1S printer. The material we're using is PLA, so very standard stuff. And as you can see here, the printer is already full. Those are all parts that are used in the machine here. Of course, afterwards you can come forward and look to it first, and you can get some M&Ms afterwards. So yeah. Ta-da! First prototype of the machine with M&Ms and a dash to it. So that looked very promising. Next, let's talk about the embedded Flutter set. Now comes the theoretical part. We have to do that. So yeah, embedded Flutter. Why are there different options for Flutter? I mean, we just want to run a Flutter application on a Raspberry Pi. Isn't all of this Flutter? And it is, but to work on different platforms, Flutter uses the so-called embedders. And if we run Flutter on iOS or web, we normally use the official embedders, which are shipped to Flutter. These connect Flutter applications to the target system where it is running. But besides those official embedders, there is also the option of using custom embedders for devices and platforms that are not yet officially included. Or maybe it's just some, even if it was included, that platform, we could write another custom embedder that maybe uses other dependencies, makes a few things different, and is a competitor to the original Flutter embeddor. So, and that is what those Flutter Pi, Flutter eLinux, and IVI home screen are, custom embedders. So if we look at the options we have if we want to run Flutter on a Raspberry Pi, we will see that it is always Flutter. One time with the official Linux embedder, and the 3 other ways are with custom embedders. So you may ask yourself why we need this. More theory coming. So to understand that, we have to look at all the components that play a role on our embedded Linux system when we want to show a Flutter application. So it's not just software parts and it's not just hardware parts, it's both. As you can see here, we start with the GPU, of course, followed by the GPU driver. They connect to graphics APIs such as OpenGL, Vulkan, which connects to the operating system and through to the display server protocol, graphics toolkit, libraries such as GTK and GDK. And finally up there, then comes our Flutter embedder, and on top of that, our Flutter app with the engine, everything running. So we don't want to get too deep into this. We just want to give you everything you need to know to make the decision which embedder you should use and how you can decide that and what is what around you. So let's look at some examples. Example 1, we're using some custom electronics built on the basis of an NXP IMX8 microcontroller. This is a widely used microcontroller right now. So if you maybe ordered a fridge with a touchscreen that is delivered in 2 weeks, chances are that there actually really is Flutter running on it to show that on the touchscreen, and that is run by an IMX8. So a lot of hardware with good visuals on touchscreens right now use this microcontroller, and also for the next months, years, this is just a widely used option. So in this option, we're using a custom Linux built by Yocto. This is very common in the embedded world. So you're crafting your individual Linux with all the components you need for your embedded application. So you're having recipes, and you're instead of developing the Linux, you develop what is needed to then create the very own Linux system you need. So Yocto, really very common. And in here, we see we don't have any graphic toolkit or library present on the system. No GTK and no GDK. That's also very common on embedded systems because you only want what you really need on there. Really good fit here is IVI home screen because it works great using Wayland, the display server protocol that we have here, and without GTK and GDK at all. Also Vulkan, if you look into their repository, you'll find out that they tested this very well. So first try for us, if we have this set up, would be trying IVI home screen. Example 2, NVIDIA Jets Nano. Again, another custom Yocto build, no GTK, no GDK on the system. We don't even have any server protocol running. It's also very common. Instead, we use what is called so-called DRM, Direct Rendering Management. Perfect for using Flutter-Pi. It works without GTK, without GDK, and with Direct Rendering Management. Next example, Raspberry Pi 5 with Raspberry Pi OS. On Raspberry Pi OS, we have GTK and GDK present. We need that as dependency for Flutter on Linux. We use Wayland. X Windows system would also work. They just switched with the newest Raspberry Pi release. Don't need to go further down there. You just need to know what will work. Therefore, to get started with Flutter development on the Raspberry Pi 5, we can just go with standard Flutter Linux, with the standard Flutter Linux embedder. So in conclusion, to decide which embedder you should use for your embedded Flutter application, you need to find out what your target system is. Not only the hardware, but also the software. Do you have GTK, GDK available? Then you can just start it off with Flutter Linux and at least start there. That's mostly what's limiting you there. Do you have a display server protocol at all? Do you have no display server protocol at all? Try Flutter-Pi. Are you using on your system Vulkan instead of OpenGL ES? Go for IVI home screen. So to find that out right now, yeah, it's not the best work, but you just have to read up the repositories, find it out. The information is not in one single point. We're kind of trying that with the presentation here, but as I'm mostly talking about it, it's maybe not the best place to look it up. So you have to look into the repositories, find out what the dependencies are, and then decide, do you have the dependencies for one of those embedders? If it's standard Flutter, it's the easiest of them all. But after that, you can decide for an embedder. After that, you have to find out if the performance on the device is what you expected. Do you have chunk? Is it fast enough? And after that, if embedder it is sufficient, you could try and find out maybe the performance is even greater if you use another embedder. So you just have to try it out, find it out. Maybe people will document it in the future. We're trying that. We're doing that here. We made some tests. So we want to write that up on the internet. So in the future, you don't have to look it up anymore. So you'd rather know, okay, we want to go this hardware setup. We go this way. But in conclusion, we can say for all of you who want to get started, for Raspberry Pi 4, 4B5, with Raspberry Pi OS, so the official one, you can go and start off with standard Flutter. Spoiler, the performance will be good enough. So back to our original question. For our use case, we could go with option 1, the standard Flutter Linux embedder. But that's not what we're doing, because Flutter Pi, when we try it in comparison, just is so much better, even performance-wise, that we want to go with Flutter Pi, because in this way we can also show you how to set it up. So finally, the theoretical part is over, and we're getting to the interesting stuff, and that's where my colleague Payam will take over. So Payam?
So thanks, Moritz. And all right. So we already talked about hardware and the decisions that we need to make for embedder and the other tools that we need to take. And now it's time to talk about development process. So there are several ways that you can start writing your code and run it on your Raspberry Pi. The first one is to just jump on your Raspberry Pi directly and install everything there and so on. So for that, you need install the OS, and after that, you need to add your connectivity like the mouse, keyboard, and display, and so on. And after that, you can just install the Flutter with the dependencies that you need, the environment variables, and so on. So at the end, you can install your IDE, that could be the VS Code in here, and write your code and try to run it on the Raspberry Pi. But there is a problem in here. We are Flutter developer. The DX in here for us is a bit different. We used to use our laptops to install everything there and just run it on our target device. That could be our emulator or our mobile app, or in this case, the Raspberry Pi. So the question is, could we have the remote debugging with the Raspberry Pi also? And the answer to that is yes. So we made the Snap CLI for that. And basically, Snap CLI helps you to set up your Raspberry Pi from scratch and helps you to have the remote debugging. Basically, it is creating the passwordless SSH connection for you, then install the Flutter or any other embedded that you choose with all the dependencies, steps, so on. And at the end, it will add a custom device to your Flutter SDK to make the remote debugging possible. So let's check it out together. The Raspberry Pi is a Dart CLI, so you can just enable it by pub global activate command. And after activation, you can just use the bootstrap command that we have in here, and bootstrap command helping you to set up your Raspberry Pi. In here, you just need to select your Raspberry Pi type, add your IP address, username, and at the end, the password. It will create the SSH connection for you in here. And after creating that, it will go through your Raspberry Pi to install everything for you. So this is the setup part. And yeah. So the Flutter Pi is just installed there. So as a result, if you check out the devices list command, we can see our Raspberry Pi is just there. That means like if we create a project and open it with our IDE, in the section that we have for the devices in the bottom right, we can see we have a new target device that is our Raspberry Pi. So you can just go there and target it as a device and just run your app on your Raspberry Pi. And this is remote debugging that we have in here. Yes, it is here. So it is running from our laptop with a Wi-Fi on our Raspberry Pi with a remote debugging. But the cool part is, with this tool, we can have access to the hot reload, hot restart, and dev tools and any other dev any other tools that we are using in our common daily use cases. So you can just run your app with a hot reload, try to improve your UI, check it out, and so on. That's so easy. So we also learned about the development process. The other question that we have is how we can control the servos from our Flutter app. So it is very common that in embedded projects that we have some kind of third-party modules, like it can be actor, sensor, servo, or anything else. But the thing we should keep in mind is that the devices like this, when they are coming to market, they are always coming with some kind of library that is written in Python or C++ or so. So, to be able to control the servo from the Flutter app that we have several options. The first one is to use a Dart plugin. We can create a Dart plugin for it, but for that we need to go to the data sheet that we have for the device. That means we need to read everything there and understand it, and at the end transfer it to the Dart code. So with this option, we cannot use the library that already is there. The second one is using MQTT protocol, and we can run an MQTT router on our Raspberry Pi, try to connect with the library that we already have, and in the other side, we can use an MQTT client on our Flutter to just try to control the servo motor. The third approach is like the second one, but instead of MQTT protocol, we are using the REST API. We can just run a Python backend and a REST API in our Raspberry Pi and just try to reach it with the Flutter app with the HTTP or DIO package that we have. And the last one is dbus, and we choose dbus because dbus is already running there. It is running on Raspberry Pi or any other Unix-based devices. So what is dbus? Basically, dbus is an inter-process communication system that allows different services, applications, and components to talk to each other in the Linux systems. And we have mainly two differences of dbus. The first one is the system bus that is used for system-wide communications, like we have a service for network management or hardware control or so on. And if I want to make an example for you, would be if you have an application that has dependency to internet, you can just listen to the network management service that we have in Service Bus, and whenever the device is connected to the internet, you will notify by some event, so you can do something. The second one is the session bus, and it is used for the messages related to the user session. That means scoped by the user. So for each user, we would have different session bus. And it is just allowing the desktop application to talk to one another. So if you want to define the service on a dbus, there is a structure. First, you need to create a service object, and inside your service object, you need to have some interfaces, and inside each interface, you can have different methods, signals, or parameters. So we decided to use session bus, and we wanted to use the library that we already have for the servo motor to be able to control it. So we made a service with the Python, and inside that service, we added the Python library that we have for the servo motor and added to the dbus. And in the other hand, we have the Flutter app that has a dbus client, so we can communicate with the session bus and try to control the server that we have in here. I already told you that we have some structure to use it to define a service for dbus, and it is like that. So first of all, you need to define a service name that must be unique, and object class, and inside your object you will have interface, and inside your interface you will have different methods. So the service for us is like that. We have that service name, and object, and interface, and beside that we define two different methods like get all motors states and throttle motor. So let's jump into the code. This is the Python service that we have, and the first line is related to the main function that we have for our service. So in the first line, we are just getting the main loop, and in the second line, we decided to use session bus. So we are getting the session bus in here. We are defining and adding our service name to the session bus and creating our servo controller, that is our object. And at the end, we are trying to just run the main loop to listen any client that we have. This is our class for the servo controller, and as you can see, it is inherited from dbus.service.object. So basically, it is a service object for the dbus, and this is also the constructor. Nothing special in here. We just initializing the stuff that we have, like I2C, PCA, and our servos. This is our getAllMotors state method that we have. Nothing special in here. We're just returning the current states of motors that we have in here. But the thing that is important is we should annotate it with some kind of interface that you can see it in the top. And we have in signature and out signature that is related to the parameter that we have for our method and the return type. So in here, we don't have any parameter, and the return type is map of integer and string. The other method is related to throttle motor, and it will get an motor ID as a parameter, duration, and throttle. And basically, it is trying to turn the motor for a while, and after that, stop the motor. It is also annotated by interface, and as you can see in signature and out signature, we just define the type of parameter and return type that we have. That was our Python service, and now it's time to talk about the Flutter app. So to create a dbus client for the Flutter app, we have a package that is called dbus, and it is maintained by the canonical. So to do that and use that, I created a dbus data source, as you can see it in the bottom. And it needs a client and a remote object. So for the client, we decided to use session bus. And for the remote object, we will pass the client, also the service name that we defined in our Python service, and the object pass. And our methods to get the states of the motors is pretty the same, the Python. In here, we are using the remote object.call method, but we need to pass the interface name and the method name that we already defined there, and just use the signature that we have there. And also the throttle motor is the same, but we need to add some parameter to it. And as you can see, we have dbus int32. It is part of the package that we already added to our application. Also, the return signature in here is B, that means it's Boolean, so we will understood that the function is just done or nothing just happened by that. So, okay, so this is everything we did to make the M&M machine, and if you liked it, you can come closer to check it out and try it. And at the same time, we would love to answer your question.
That's it.
Yeah, this is it.